Hello, everyone. Today, I'm going to post solution for daily questions that I post on my page, Math Tribe. So if you like to exercise your brain, give it some food to work on, like my page, Math Tribe. And yeah, you'll see all the questions. So, and every weekend on Sunday, I post solutions for the question that I posted during the week. Okay, so let's start. Let's start. So first question that was posted is, if we have 6 sticks of length 1 centimeter, 2 centimeters, 3 centimeters, 2001, 2002, 2003 centimeters. If you have to choose 3 of these sticks and form a triangle, how many triangles we can form from these 6 sticks? And to figure out or to calculate, we need to remember triangle inequality theorem that says that sum of any 2 sides of a triangle in a triangle must be greater than the third side. So we have a triangle, right, with sides A, B, and C. So what this theorem says that it says, so A plus B must be greater than C. Same with A plus C must be greater than B, and C plus B must be greater than A. Why? Because if they would be, let's say, if we're going to put equal sign here, so we can end up in a scenario then, let's say, A equals to 1 and B equals to 2 and C equals to 3, right? So 1 plus 2 equals to 3, right? So in this case, we won't be able to build a triangle because side A and B, they will coincide with side C, right? So we won't be able to build a triangle. So basically, it will be straight line, right? Straight line. So let's say this is A and this is B, right? So A is 2, B is 4, and C is 6, right? So you see that A plus B equals to 6, and we can't form a triangle. It's a straight line. Okay, so let's see how many options we have given data in the question. So with we won't be able to form a triangle with such that one of the side equals to 1, right? Because like 1, 2, 3, right? So 1 plus, let's say triangle 1, 2, 3. So 1 plus 2 equals to 3. So it won't be a triangle. Same with any other option we choose. 1, 2002, 2001, and 2002. So again, we won't be able build a triangle because 1 plus 2001 equals to 2002. And we know it must be greater than 2002. And same with triangle with sides 1, 2002, 2003. So we won't be able to build such triangle for the same reason, because 1 plus 2002 equals to 2003. Okay, so let's try to build triangles with side such that one of the side equals to 2. So how many triangles we can build? So we can build 2 triangles. So one of them is with sides 2, 2001, 2002, and we can see that triangle inequality theorem holds here. So second option will be 2, 2002, 2003. So again, triangle inequality theorem holds here. So next option, and yeah, that's it with triangles such that one of the sides equals to 2. Let's pick up with side 3. So we can build 3, 2001, 2002. Fourth option is 3, 2001, 2003. Okay. So fifth option will be 3, 2002, 2003. And 6 options, and yeah, we're done here with triangles such that one of the sides equals to 3. And last option is triangle with sides 2001, 2002, 2003. Okay, so we have 6 options. So correct answer is D. Okay, let's move forward. Let's move forward. Next question. In the picture, there are 4 overlapping squares with sides 11, 9, 7, and 5. How much greater is the sum of the 2 gray areas than the sum of the 2 black areas? Okay, so overlapping, right? So what does it mean overlapping? Right, so we can see here, right, this area. So it means this area that overlaps, it's equal, right? So this area, we take this area out, same area from both squares, right? So if we have, let's try to build a formula here to understand how it works, right? And then I'm going to build another triangle over here. Not triangle, sorry, square. I have triangles in my mind. Right, so we see this square is overlapping, right? So we subtract this area from both squares. Let's say this side is 3. Okay, and yeah, so we have 2 squares. Okay, so first square area of the first square is 3 times 3 equals to 9. Same with second square, equals to 9. And then we take, so we're trying to find difference of these squares. So probably I need to reduce something here. So let's do 4. Okay, so we're trying to find difference of these 2 areas, right? So this will be 4 times 4 equals 16. Right? So then what do we have? So we have, then we take this piece out from both squares, right? So then first square will be 3 times 3 minus 1 times 1. We're trying to find the difference of these squares, right? Areas of these squares. 1. So it will be 16 minus 1 minus 9 minus 1. So we have 15 minus 8 equals to 7. Right? And if we wouldn't have these two squares overlap each other, right? Right, so 3 times 3 minus 4, 4 times 4 minus 3 times 3 is 16 minus 9 equals to 7. So what I'm trying to say here, so we can ignore this overlapping area because we will get same result. Because why? Because we subtract same area, same number, same area from both squares, right? So we take out same number. So the result, and we know if you subtract two numbers and then you reduce this number by the same number, the result will be the same. So to answer our question, so the difference between squares with gray area and squares of black area will be 11 square plus 7 square minus 9 square minus 5 square. We have 121 plus 49 minus 81 minus 25. And the answer is, let me calculate, 121 plus 49 minus 81 minus 25 is 64. 64. The correct answer is D. Next question. Anne and Barbara have the 3-digit number 888, which is clearly divisible by 8, and changes two of its digits in order to get the biggest 3-digit number, which is still divisible by 8. Barbara changes 2 of the digits of 888 in order to get the smallest 3-digit number, which is still divisible by 8. Okay, so we have 808. So we just need to add multiples of 8, right? And to this number to get the biggest 3-digit number that is divisible by 8. Right? So plus and it will be 984, right? So 984. We added to this number 96. 96, and we've got 984. And why this number? Because we can add more to, we still can add 8 to get right? We still can add 8 to get 992, right? And it's still divisible by 8. But the condition is she changes only 2 digits, right? So one of the 8's supposed to remain, to stay in the number. So we changed first digit and last digit, and we've got 984. So we changed 2 digits to get the highest 3-digit number, which is divisible by 8. What about smallest number, right? So we can pick up the smallest we can pick up smallest number that divisible, 3-digit number that divisible by 8. I think it will be 104, right? But again, the condition is we change only 2 digits, right? And keep adding, and we can keep adding 8s. So if we add 8, we get 112. Then we add another 8 is 120. And if we add, so I can put equal signs here, right? So, okay, yeah, it's wrong expression that what I'm writing here, but yeah, I'll keep it. I can put equal signs in between. So, and 120 plus 8, we get 128, right? So this will be the smallest 3-digit number that divisible by 8, such that we change only 2 digits, right? And one of the digits is supposed to stay 8. So we've got 128. So what's the difference between them? 984 minus 128. It will be 856. And correct answer is C. Okay, next question. Mike has 42 identical cubes, each with the 8 centimeters long. He used all cubes to construct a rectangular prism. The perimeter of the base of the rectangular prism is 18. What is the height? Okay. So 42 identical cubes with each cube has h that equals to 1 centimeters. 1 centimeter, it means that volume of each small cube is 1 cubical centimeter, right? And it means that because we have 42 of them, that volume of this prism, rectangular prism, is 42 centimeters cube, right? So, and we know that volume equals base, length times width times height. And perimeter of the base is 2 lengths plus 2 widths equals to 18. So it follows that length times width equals to 9, right? Okay. Let's try to figure out how many options we have. What are 2 numbers that adds up to 9, right? So it must be, so those 2 numbers must be whole numbers, right? Because we deal with volume is a whole number, and each edge of small cubes is 1 centimeters long. So we can't have fraction here because we deal with whole numbers, right? Because height can be fraction. Why? Because each edge is whole number. Okay, so what two numbers adds up to 9? So we have 5 plus 4 equals to 9. 6 plus 3 equals to 9. 7 plus 2 equals to 9. And 8 plus 1 equals to 9. Right? So 5 times 4 equals to 20, right? So to find height, we divide volume by length times width equals to height, right? So if we divide 42 by 20, we get fractional answer. So it doesn't work. 6 times 3 equals to 18. Again, if we divide 42 by 18, we get fractional answer. 7 times 2 equals to 14, right? And 42 divided by 14 equals to 3. Okay, so, and last answer I'm gonna write it down, but it's not correct, the correct answer, right? Because, right, 8 times 1 is 8, and 42 is not divisible by 8. So correct answer is 3, is C. 6. So in this question, we must use our imagination, right, and logic. A straight line is drawn across a 4x4 chessboard. What is the greatest number of 1x1 squares which can be cut into 2 pieces by the line? Okay, let's try to figure out. Right, so it seems like we only can, if we draw a line, it can cut only 4 squares, right? Doesn't matter how we cut them. So the line can go only through 4 squares, even diagonals, right? Looks like. But if we draw our diagonal not from corner to corner, but we're gonna move it a little bit, right? Let's say from here. Let's see what we're gonna get in this case, right? So we have 1 square, 2, 3, 4, 5, 6, and 7, right? So this red line goes through this square, this square, this square, and this square, and these 2 squares. And this square. This is this, and this 2. So 7 squares. 1, 2, 3, 4, 5, 6, 7. Correct answer is D, 7. Next question. When going to Rimini by train, Lisa sat in the 7th carriage from the front, and Marco sat in front of her in the 6th carriage from the back, with 1 carriage between Lisa and Marco. How many carriages were were there in the train. Okay, so we know that Lisa sat in the 7th carriage from the front. So this will be front. So she was sitting in the 7th carriage. So it's 5, 6, 7. So Lisa is sitting here. Marco sitting in front of her, one carriage in between them, right? So Marco sits here because it says that there is one carriage between Lisa's carriage and Marcos, right? And what else do we know about Marcos? He sits in the 6th carriage from the end, right? So 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6. Okay. How many carriages were there in the train? Okay, let's count. So I started to count from the back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the correct answer will be D. The most logical answer here is D. And the last question. In a triangle ABC, the angle C is 3 times bigger than the angle A. The angle B is 2 times bigger than the angle A. Then the triangle ABC. Okay, so we need to find what type of triangle. Okay, so let's draw triangle. Okay. So A, B, C. So let's X be measurement of angle A. So it's X. So C will be 3 times bigger than A. So C will be 3X. And B is 2 times bigger than angle A. So it will be 2X. And we know that sum of all angles in the triangle equals to 180 degrees. So we just add all 3 angles. So X plus 2X plus 3X equals 180. So 1 plus 2 plus 3 is 6X equals to 180. X equals to 30 degrees. So then we have A is 30, B is 60, and C sub must be 90 degrees. Yeah, it's supposed to be we see right triangle. So the correct answer is has a right angle, right? Because it's not equilateral, it's not isosceles. It doesn't have obtuse angle, and not all angles are acute angles, right? So the correct answer is D. It has right angle. So that's it for today. Thank you for watching this presentation. I will keep posting new questions on my page. Again, if you like to solve this type of questions, subscribe to like my page. And yeah, I will start this week to do reviews for Math 30, because some students do write final exams in spite of our government made it optional. but some of my students decided to write exams, especially grade 12 students who wants to get good marks and go to universities. So I'll start posting videos with Math 30-1 final exam review this week. So stay tuned, and I'll see you guys around.